Hey guys, let's do it. So we're going to do notes and questions. So you should have taken notes here on these sections and watch on Teams. And we did example 1, 2, or we didn't do 2, but we took quite a lot of notes. There was a lot of theorems we filled in here. We did example 3 and 4 on both parts, but you might have some more notes here because we did 6 theorems today, okay? So then, after those notes, you'd be doing questions 9, 12, 13, 14, 19, 23, 24. Those are the questions today in our assignments. So let's take a look. So it looks like I have no assignments here. These would just be kind of extra questions. Ooh, but this is a good thing. This is pretty close to the question that they asked, similar to the discussion. So if you didn't answer this discussion question, make sure you do that for your 5 points. Be part of the discussion today. Okay. So question number 9 is our first question of the homework, and it says, what is the error the student made? So here's what the student wrote. Given that angle 1 is equal to angle 2. That's just given in the picture. Okay, so given those are equal, that's good. Then it says angle 1 and angle 3 are also equal. So angle 1 and angle 3 are also equal because of vertical. That's good. I like that. Then it says by transitive property, angle 2 would have to equal angle 3. That's all good. But now it's saying because of the converse corresponding angle theorem. So let's think about what the converse corresponding angle theorem would state. The converse corresponding angle theorem would say if angle 2 is congruent to this angle. So that's not an angle we're talking about. This is maybe a fourth angle that we don't know. If those two angles were equal, so if this angle is equal to this angle, then these two lines would be locked into place. And so that's where I see the error here. So the error is we need angle 4, which is an unknown angle here. It's an unknown measurement at this point. We need angle 4 to be equal to angle 2 in order to say converse cap. Okay? If angle 4 and angle 2 were in fact equal, then it would lock these into place and we could make the conclusion that those are parallel. But that's not what we have going on in the picture. Okay. Next question, angle 12, or number 12. So let's take a look. 12 states angle 2, what if they told us angle 2 is congruent to angle 3? Then that would lock that into place. So I'm just going to trace both sides of angle 2, this one, and both sides of angle 3, this one and this one. I could also redraw it over here. Angle 2, trace both sides. And angle 3, trace both sides. All right, so if those were locked into place, then that would force this line, Q, to be equal, not equal, but parallel. That would force P to be parallel to Q. Now we learned today that that's what that symbol means. So if that symbol throws you off, you could also write it in word form. P is parallel to Q. Okay? Now let's look at number 3. 6 and 7. What if 6 and 7 were forced to be equal? So if we force 6 to be equal to 7, So trace both sides of angle 7, trace both sides of angle 6. That would also, looks like, force P and Q to be parallel. So same answer here. P is parallel to Q. P, Q would also be forced to be parallel if 6 is equal in measurement to 7. Okay, and last one on this picture. It says, what if angle 4 and 1 are forced to be equal? So 4 and 1. All right, so if those are locked into place, I'll trace both sides of 1 and both sides of 4. Now it looks like that would force R and S to be parallel. So R would be parallel to S. Now we got to be careful because it also says which lines would we conclude would be parallel and then which justifies our theorem. So let's look at the location of these angles. 2 and 3 should be corresponding. So this would be the converse corresponding angle theorem. Okay. Now let's look at 6 and 7. So 6 is here and 7 is here. And they're on the opposite side of this transversal S. 6 and 7 are on opposite sides. And they're inside this road area, right? So that would be alternate interior angle theorem. Converse, though, because I'm working in reverse today. All right, angle 1 and 4. So angle 1 and angle 4. Trace those lines. They're outside of this road here, right? They're outside of the road, so exterior. And one's on the left of Q and one's on the right of Q. So that's converse alternate exterior angle theorem. Okay. Now let's take a look at 19. So it states here, so let's look at the theorem. Which theorem justifies your answer? So if we want to know what value of x would lock this into place, we notice these two are obtuse, so they wouldn't add up to 180. They should be equal. But let's look at what their location is. It looks like they're not in the road. They didn't get highlighted. And one's on the left, right? One's on the right. So this would be converse AEAT. They're on alternate exterior angles. And so we knew from our class, alternate exterior angles are congruent. So we can set these things equal to each other. So if we set 10x plus 5 equal to 12x minus 9, I get x is 7. Now I could plug this back in and just double check my answer. So 10 times 7 plus 5 is 70 plus 5, 75. And 12 times 7 be 84 minus 9 would be 75. Okay, yep, so they are congruent and x would make, lock these parallel lines into place. All right, check out the next video for questions 23 and 24.